Hi guys, how are you doing? It's science time, and today I would like to talk about the specific latent heat and the specific heat capacity. So guys, today before going through this video, I will be asking you to subscribe my channel since this video is going to be really great, a great concept. Please like, comment, share, and if you haven't turned on the bell yet, please do it. So in that case, you could be able to analyze my upcoming videos. So let's go. So guys, as you can see in these two pictures, in the left picture, it's talking about changing phase, which we are going to understand that this is about the latent heat of vaporization or fusion. So this process happens until now. Let's know only that this process happens while the phase change occurs. And also in specific heat capacity, we can see that there are like nearly 10 or more than 10 substances which are being heated by a constant energy which is being applied to them, and also with the same mass of each substance is being used, but the temperature is changing, and let's say in this case the temperature is increasing in different rates. So we can see that the specific heat capacity of different substances are totally different. They vary. So the specific heat capacity. Specific heat capacity is the energy required to raise the temperature of 1 kilogram of a substance by 1 Celsius. Don't forget this. So the specific heat capacity, in other words, is the energy needed to increase the temperature of a single kilogram of a substance by 1 degree. The unit of specific heat capacity is joules per kilogram times degree times Celsius. The formula can be considered as below. Energy required, or let's say in other words, energy needed, equivalent to mass times increase in temperature times specific heat capacity. There is a tip here that the specific heat capacity of each substance is different. And why? Since the materials which exists in each element completely varies. Therefore, two substances will increase temperature at different rates. Mass has to be constant if you want to compare. So guys, don't forget this. When we want to compare two specific heat capacities of two different substances related to the increase in their temperatures, the mass has to be all the times constant. Therefore, two substances we could be able to ensure we are capable enough to ensure that two different substances will increase temperature at different rates while the same energy is being applied to them. So now, based on these informations, there is a warm-up question here that it says the specific heat capacity of steel is 420 joules per kilogram Celsius. How much energy required to heat 5 kilograms of steel by 20 Celsius? So now we have to refer on the numbers that we have. Increasing temperature 0 to 20, so 20 Celsius, mass 5 kilogram. It's already it has been already considered as the SI unit of mass, which is kilogram, and also the specific heat capacity, which it is 420 joules per kilogram Celsius. So based on the formula that we have, the energy required equivalent to temperature, or let's say increase in temperature, times mass, times C, or let's say specific heat capacity. Therefore, after putting those numbers in order, 420 times 5 times 20, which is equivalent to 42,000 joules. So, and now, specific latent heat. So guys, what is it? Specific latent heat is the energy required to change the phase of 1 kilogram of a substance, and no temperature is needed. Don't forget this. And why? Since we are not mentioning the temperature, as specific heat capacity. And why? Since while the substance is changing its state, the temperature remains constant. Don't forget this. While during the phase change is happening, is occurring, is involving, the temperature remains constant. And guys, don't forget that these two, specific latent heat and specific heat capacity, are totally different. The one that like we are talking about is related to the phase change, but the specific heat capacity is related to like the energy required to raise the temperature of a single kilogram of a substance by one temperature, by a single Celsius. So don't forget this, that they are totally different, with different descriptions, with different definitions. And now guys, specific latent heat is measured in joules. Don't forget this. The formula for calculating the specific latent heat is shown as below. So as you can see, energy supplied divided by mass, or let's say joules per kilogram. There's a tip here, guys, that we have different types of latent heat. And why? Since we have to determine the phase change. Latent heat of vaporization or latent heat of fusion. Latent heat of vaporization means boiling or evaporation, the time which the phase change happens from liquid form to liquid form to gas form. And latent heat of fusion means from solid form to liquid form, or let's say, in other words, melting. So guys, based on these informations, there is a warm-up question here that it says it takes 4,500 joules to turn 2 gram, there is a typo here, 2 gram of water at 100 Celsius into the steam. Calculate the specific latent heat of vaporization of water. So guys, based on these informations, based on this specific and certain question, we know that we have two things: the energy supplied and the mass. So guys, we know that the mass, it says 2 grams, so we have to convert it into SI units. So in that case, we are going to divide it by 1,000 to get its kilogram, which in this case, it is 0.002 kilogram. And also the energy supplied, it is already in SI units, so we are going to write the same thing, 4,500 joules. So now we are going to refer on the formula, which it says energy supplied divided by the mass. After putting the numbers, 4,500 divided by 0.002, equivalent to 225 times 10 to the power of 4. Or let's say, in other words, 2,250,000 joules. So guys, based on these informations, I have prepared 4 questions, 2 related to specific heat capacity and 2 related to specific latent heat, for encouraging you to comprehend this video, or let's say this concept, much better. So be with us. Specific heat capacity, question number 1 and question number 2. The specific heat capacity of water is 4,180 joules per kilogram Celsius. What is the final temperature of water if 10 kilograms starts at 20 Celsius and is given 1.672 times 10 to the power of 6 joules? So guys, we want the final temperature. Don't forget this, not the increase in temperature. So based on the formula, after putting those numbers with their SI units, after getting the answer, that single answer is not our answer, since that number that we are going to get is going to be the increase in temperature, but we don't want the increase in temperature, we want the final temperature. And also we have the startup temperature, so we can calculate and solve the final temperature much easier. So guys, the increase in temperature is equivalent to energy required divided by mass times C, or let's say, in other words, specific heat capacity. Therefore, 1.672 times 10 to the power of 6 divided by, brackets open, 10 multiplied by 4,180, bracket close, equivalent to 40. After using our calculator, after calculating it, we are going to get 40. So the final temperature, we know that the final temperature is equivalent to the initial temperature, which in this case it is 20, plus the increase in temperature. And we know that we got the increase in temperature, which is equivalent to 4T. So 20 being added by 40 equivalent to 60 Celsius. So guys, let's say in other words, when 1.672 times 10 to the power of 6 joules is being applied to a 10 kilogram of a substance being started from 20 Celsius, and that substance has the specific heat capacity of 4,180 joules per kilogram Celsius, the final temperature is going to be 60 Celsius, as we are going to refer on the formula. So the second question, it says a beaker contains 1 kilogram of water at 20 Celsius. A student heats a 1 kilogram block of aluminium to 100 Celsius and then drops it into the water. After a short while, the water and the block of aluminium have both reached a temperature of 38 Celsius. The student said that this showed that water has a greater specific heat capacity than aluminium. So, is he correct? Explain your answer. So guys, in this question, we have to refer on the description, a simple introduction to the specific heat capacity, that we are saying that specific heat capacity, or let's say in other words, C, is the energy required in order to raise up the temperature, in order to raise the temperature of 1 kilogram of a substance by 1 Celsius. So in this case, based on the information given, change in temperature of aluminium is much more than the change of temperature in the water. This means that more energy is required for the water to increase its temperature until a certain amount. Thus, water has a greater specific heat capacity. So guys, and now question number 3 and 4 related to specific latent heat. So, question number 3. How much energy is needed to melt 150 grams of ice at 0 Celsius to water? As you can see, the melting point of water, as everyone knows, it's going to be melted, the ice is going to be melted, and it is going to be converted into water at 0 Celsius at the same temperature. And the information is given, specific latent heat of fusion of water equivalent to 334 kilojoules per kilogram. So guys, we know, as we are going to refer on the formula, that the energy required is equivalent to specific latent heat times mass. Based on the information given, the specific latent heat of fusion, indeed, for melting of ice, for being converted into water, it is 334 kilojoules per kilogram, or let's say we have to convert it into another unit, or let's say SI units. Therefore, 334 multiplied by 10 to the power of 3, or let's say in other words, 334,000 joules per kilogram, and mass, based on the information given, 150 gram, which is going to be converted, its unit is going to be converted into SI units, so 0.15. So after putting these numbers that we have in the formula, 334 times 10 to the power of 3 times 0.15 equivalent to 50,100 joules. It's really simple. And the last question, question number 4, about specific latent heat. How much water at 100 degrees would be turned into steam, that means boiling point, or let's say vaporization, of the same temperature by 678 kilojoules of energy? So, specific by the information given, we know that specific latent heat of vaporization of water, it is equivalent to 2260 kilojoules per kilogram. So, the answer is going to be based on the formula that we know, that we analyzed before in the last slides. Mass equivalent to energy supplied. That means the energy that we supplied, or let's say energy required, divided by specific latent heat of, in this case, vaporization. So we know the energy, 678 kilojoules, or let's say after being converted into SI units, 678 times 10 to the power of 3 joules, or let's say in other words, 678,000 joules, and the specific latent heat as it is given also 2260 kilojoules per kilogram, converting it into the SI units, equivalent to 226 times 10 to the power of 4, or let's say in other words, 2,260,000 joules per kilogram. So after putting the numbers that we have and the formula, as we know the formula is that the specific latent heat equivalent to energy supplied divided by the mass. So here it wants the mass. So we want to bring the mass and we want to convert the mass as it is going to be the subject of the formula. So in that case, as we are going to bring the mass, which is in the denominator, in the subject, we are going to put energy required in the other sides, which in that case, it would be mass equivalent to energy required divided by specific latent heat. So after putting the numbers, 678 times 10 to the power of 3 divided by, bracket open, 226 times 10 to the power of 4, bracket close, equivalent to 0.3 kilogram. So guys, that's all for today. Don't forget to like, share, and comment. And if you haven't turned on the bell yet, please do it. And guys, feel free to ask any educational questions that came to your mind so you can comprehend the concept much better. So guys, hope you a great day and see you in our next video.